Let's talk about functions in C++. Now, functions are used to define reusable code, so you don't have to repeat code over and over again in your program. This whole style of using functions to define reusable code is referred to as modular software development, right? So functions basically are a sequence of statements. We have seen several functions already. We've seen printf that is used to output data. We've seen other functions like int, which are used to convert something into an integer, right? Uh, a program is said to call or invoke a function to execute the statements that are in its body, right? Sometimes we pass data into the function. For example, here you have printf, and we're passing in the string hello into it. Here, the string hello is called an argument that is passed into the function. Now, there are two types of functions. There are void functions, and then there are value returning functions. The function printf is an example of a void function. A void function doesn't return anything. It just has some side effects, right? In this case, the side effect is outputting something to the screen. Another example of a void function is exit, right? Which just exits the whole program. It doesn't really output anything, right? To see functions that return a value, we're going to use a new library called CMath. Now, CMath library is very useful because it gives us a number of useful math functions, such as ones to do square root, to get us absolute values, or to raise something to the power of something else. So let's take a look at an example where we're using the CMath library. The very first thing we have here is we have this include directive that pulls in the CMath library, right? And then we have our main function. Let's look at that in a bit of detail. We start by declaring a couple of doubles. Then we prompt for a number and read it into the variable num, right? And then we have this function call, right, which gives us square root of num. And this is a value returning function. And it returns the square root of num and gives you back a double. So actually is returning value. We take that value, we assign it to answer, and then we print that answer, right? So actually let's try this out and see what it looks like. So we'll copy it. We'll go to our IDE here, and then we'll paste it. And let's run it. We enter something like 88. It'll give us its square root. Now, in this case, we're only passing a single value, but that doesn't need to be the case. There is another function. Let's go back to our lesson called POW, right? That takes in two different values. The POW raises something to the power of something else. So it takes a base and takes an exponent, and it raises the base to the exponent. So it's 2 to the power of 4, which gives us 16. So that's what the above will print. Now, so far, we've been using functions that are given to us by libraries that we have pulled in using include directives like CMath, but we can create our own functions, right? So a function definition is, again, a sequence of statements that is run every time the function is called, right? So let's define a new function to compute the perimeter, compute and return the perimeter of a rectangle, right? So this is our function here. So let's look at this in detail. Now, the first line here is called the function header. The rest of it in the curly brace is the function body. So what's in the function header? The function header starts with a data type. This is the data type of the value returned. In this case, it's an int. It doesn't have to be an int. For other functions, it might be double or whatever. Next is the function name. Now this is followed by a set of parameters within parentheses, right? and each one has a data type and a variable name here, right? So this has two parameters, both int L and W, right? Now let's look at the function body, right? And in the body of the function, we have just two statements. The first one calculates the perimeter and assigns it to something called a variable called val, and then returns that value, right? So note that when we call this function, we pass in arguments. Each of the arguments will be assigned to the corresponding parameters. So if we were to call this with 2 and 4, uh, L will hold 2, and 4 will be assigned to W, right? So let's actually use this. We'll go back to our IDE, and we will put it in our program. So let's actually put it right here, right above main. And we'll talk about the ordering and where this should go in a future lesson, but for now, we will put it here, right? And now we want to call it. So let's replace this code here all the way to here. Get rid of this, and then we'll call it. So call it, we will basically say perimeter, and well, let's pass in 5 and 10, and let's run it. We'll talk about what exactly is happening, right? So it's prints 30. So 5 plus 10 times 2 is 30. So when we call it, control, it moves to the function itself. Each of the arguments gets mapped to the perimeters, right? So L will now hold 5 and W will hold 10. Uh, this value is computed. The return call will return the control back to the calling location and will provide the return value. That is what is going on. Okay. And that is exactly what we show here. One thing to note here is that the return statement, now return is a reserved word, will transfer control back to where the function is called, right? The data that is being returned by the return statement must match the return type specified in the function header.